Hello everyone. In this session, we will discuss some more problems. Here, the given problem is g of s equal 1 by s square plus 1 has 0 initial condition. The percentage of overshoot in step response. How much of overshoot is it having? So first, generally, he is mentioned here step response. That means input is the step. Input is the step input. That means the input is u of t, and we are giving for the transfer function is 1 by s square plus 1. So here the input is the u of t is applying to a input is the u of t is applying to the signal, that is g of s. G of is nothing but 1 by s square plus 1, s square plus 1, and it will give the output, that is c of t, and it has the negative feedback is like this, and the output value is like that. Yes, this is the given signal. So in order to find out the overshoot, first look at this is the second order system, but the given is the g of s, means the given is the open loop transfer function. That is, open loop transfer function means that given value is 1 by s square plus 1. From this we can find out the closed loop transfer function. Closed loop transfer function equal, so numerator by numerator plus denominator. So this is the numerator and this is the denominator. So we will find out closed loop transfer function is numerator by numerator plus denominator. So here numerator is 1 and denominator is s square plus 1 plus 1. So we have 1 by s square plus 2. 1 by s square plus 2. Just observe here, we have characteristic equation equal s square plus 2 equal to 0. So if you compare with the compare normal characteristic equation is s square plus 2 zeta omega n s plus omega n square equal to 0. This is the normal equation. In this there is no zeta value is 0, no damping. That means the oscillations will continuing, one thing, and the another thing is, and from this we can find out s value, s square equal to minus 2. From this s square equal to j square 2 and s equal to plus or minus j root 2, and we have the two poles. That poles are j root t is one pole, another pole is j equal to, so we are getting two poles. One pole is plus j root 2, the another pole equal to minus j root 2. So whenever these two poles are available on the imaginary axis only. The first pole is j root 2, the another pole is minus j root 2. Okay, whenever two poles on the imaginary axis, and the output waveform is like this. The output waveform is like this. Generally the output waveform is varies like this. How it varies? It's look like it will be, the output waveform is varies output varies is where like this. Okay, so that means overshoot, the overshoot value is, it has complete overshoot. Then this type of overshoot, percentage of overshoot is called as 100%. Overshoot is 100%. Whenever, generally if it is under damped system, the output will be initially increases and decreases, it will reach to steady state value. But this is due to the effect of the zeta value 0. Okay, so this is one of the problem. And the next problem is, here we have the next problem, that is the transfer function equal s square plus 9 s plus 2 by s plus 1 into s plus 3 into s plus 4 is excited by sine omega t. The steady state will be 0 at 1 radian per second, or omega equal to omega equal 3, omega equal to 4. Okay, so we need to find out omega. First, what is the given signal? So first, what is the given signal? So sine omega t is the given signal. He directly mentioned the transfer function. So he directly mentioned the transfer function. So he is applying to the transfer function, and we will get some output. We have some output. So how we can write this output? Generally, output means C of t or C of s, you can write. So here I will take it is a C of s. I will consider it is a C of s. So here the output I will write like this. The output is nothing but C of s. That value is transfer function into input. Transfer function into input generally. So here the C of s equal to, the transfer function value is s square plus 9 into s plus 2 by s plus 1 into s plus 3 into s plus 4 into input. What is input? Sine omega t. Sine omega t. But he mentioned steady state output is 0. He mentioned that the steady state output is 0. So the study here given one thing, the steady state output will be the 0. What is that meaning? The whenever t reaches infinite, automatically the complete output will be 0. The complete output will be 0 means this may be complete 0. Okay, so from this I will analyze this thing. So I will take first term. Assume that s square plus 9 will be equal to 0. So here s square equal to minus 9, s square equal to j square 9. Here we have s equal to yeah s equal to, I will write like this. So we have s equal to, I will write again j square, s square equal to j square 9, right? So both j square will be cancelled. So j omega, sorry, since you know that s value equal to j omega, just replacing s with j omega, then j square omega equal j square 9. From this we will get omega value equal to 3. So omega value equal to 3. So we will write steady state output may be at omega equal to 3. And we have another terms. Just check the another terms also. What are the remaining terms? The remaining terms is the remaining terms we have s plus 2 equal to 0 is the remaining term generally. So from this we can write s value will be right is minus 2. So I will write j omega equal to minus 2. Okay, and j omega equal to minus 2, right? So here From this we can write j omega equal to j square into 2 square j omega equal to j2 omega equal to j2. Here generally this is the radian per second, but the frequency, we know the frequency, this is the angular frequency not in imaginary terms, not in imaginary axis. This is the very important thing. And same s plus 1, these two things will be 0, this is not 0, and two cases are possible. Whenever steady state output is 0, two cases possible. The first case is s square plus 9 equal to 0. The second case is s plus 2 equal 0. Whenever I am equating to 0, we have omega equal 3. But here s plus 2 is equal to 0, then we have omega value j2. So here omega is imaginary, but here omega equal to 3. Therefore the frequency is the frequency is from these two equation 3 radian per second. 3 radian per second. So this is the procedure to do this type of problem. Whenever we have some transfer function and giving some input and finding the steady state output at which, that means he is asking to find out the angular frequency. That condition you have to follow this procedure. Okay, here steady state output 0 means only numerator will be 0, not denominator. That's why I will take s square plus 9 0 one condition, s plus 2 equal 0 second condition. From this I will get this omega equal to 3. Okay, I hope all of you enjoy the session. Thank you.